Wonderful. The sum of the measures of the interior angles. Now, some places are actually going to say the sum of the measures of the interior angles. So I'm going to go ahead and throw that in there. But the sum of the measures of the angles of a triangle. The angles of a triangle, clearly we're implying the angle that's here, not the angle that's going all the way around. Nor are we talking about the angle that's outside here. That would be called an exterior angle. So sometimes they'll say interior angle or simply just angles is implied. So whenever you have a triangle, instantly you can think that this plus this plus this is all equal to 180. Does not mean they are supplementary, but it does mean that they all sum to 180. Beautiful. Now this only applies on flat surfaces, by the way. It does not work on the Earth. The Earth is not flat, so it does not work on the Earth. That's called spherical geometry or non-Euclidean geometry. All right, so how would we set up to solve for part C here? Please tell your neighbor the super secret equation that you would write down. Not the answer, the equation. Go. Good. So 100 plus 30, put another 0 there, plus the measure of angle C, and all of that is going to sum to 180. All right, so if you did this, if you were doing a proof, you would probably actually start with all the letters, all the measures. So you would actually write this if you were doing a proof. You would say, oh, by the triangle sum theorem, this is true. Then by substitution, this is true. And then from here, you can solve it quick style. In general, you do need to show this step. I know that many of you can just plug it into a calculator real quick, or even just in your head, find out what that is. But I do want the first step and then at least the answer from there. I don't care if you show the middle work in between. And then from here, you get 50 degrees. And then you can just do a quick test with your calculator. All sum to 180. Now, of course, does this work for every single triangle on the planet? Well, with the triangles that you explored yesterday, it did work. And notice we talked about this briefly. But if we draw what is called an auxiliary line, so please write that down because it will come up, auxiliary line. You may have noticed that at some point, especially on your car, you may see a 3.5 jack, and it says aux, like that. Did you ever see that in your car or on another thing? Aux just means auxiliary. It means an additional line. So now you can plug your headphones into your car, or you can plug your, well, this is an input, so you would plug your phone into this one, and then you can listen to music through this stereo there. So auxiliary just means an extra that's outside. So notice, if we were given just this original right here, where I don't see the line, then I just have the triangle ABC. And it's hard for me to compare this 2 to this A and this C. I don't really know much. So when we draw this parallel line here, then we know certain things. All right, so with your partner, please spend a few minutes looking at A through H here and trying to fill in the gaps. Then when you're done with that, summarize the whole thing, just what were all the steps that you did real quick. Go. So let's take a gander at this one. So like we said, there is only one line that we can draw, and we did that. Only one line that is parallel to AC down below, and that's a postulate. And so we just use what's called the parallel postulate. One line only will be parallel to AC passing through point P. Okay, next we have to figure out which is angle PBC. So angle PBC is this obtuse angle here, so this whole thing. And then angle 3 is this angle there. So those two form a line. So this is linear pair are supplementary. They are two angles that form a line. They are a linear pair. Therefore, they're supplementary by a linear pair postulate, or just say linear pair are supplementary. Okay, now notice down here I have some magic. I have angles 1 and 2 showing up all of the sudden. I already know that this part would be true once we add it to the PBC. So what we have to do is effectively unpack PBC. How do we get the angle PBC? Of what does it consist? So the measure of angle PBC is equal to what? Where does it come from? How is it built? How is it made? What two angles? Angle 1 plus angle 2. And notice it says the angle addition postulate. Now, two things are kind of happening at the same time. Notice that we are using the supplementary, what supplementary means, and we're also taking the PBC and substituting in the sum right there. So together we're doing here substitution. If you wanted to be more complete and say definition of supplementary also, but substitution is the bigger one here that we're using. Okay, now what is true? What is true? So let me clean up a little bit up here. What is proved here? Well, angle 1 is now the same as angle A. Why? If we were to look at the two red and this blue transversal, and you don't need to draw those arrows, but I'm just drawing it so it's a little bit more clear. How are angle 1 and angle A related? Go ahead. So what about angle C and angle 3? Turns out they're the exact same, right? Alternate interior angles are congruent because of parallel. So notice I can say that. I'm going from parallel, which is established up in part B. I'm going from here, going to there. So I'm kind of, it's a whole different train of thought. Notice that F does not come from E. F does not come from E. F actually comes from B. Okay, so over here, F, I can say, is when we have parallel lines, then the alternate interior angles are congruent. Now what? If I have the definition of congruent angles, explain to your partner, what does the definition of congruent angles do? It converts from what to what? Great, so if we refresh, this takes us from the congruent to the equal sign or back again, depending on which direction you're talking about. So notice here, I'm starting with congruence right here, congruence, and I need to convert it to an equal sign. All right, so that means the measure of angle uno is equal to the measure of angle A, and the measure of angle tres is equal to the measure of angle C. So from there, we now can start substituting in. The A can go in for 1, right there, and the C, oops, I forgot to put the angle symbol, can go in for 3 right there. So why is that important? Because the measure of angle A plus the measure of angle 2 plus the measure of angle C all equal to 180 using our friend substitution. So what did I just prove? Substitution. I just proved that the three angles, angle A, angle C, and what we're calling angle 2 up there, all add to 180. And it never, ever, ever matters which kind of triangle it is, because anytime I draw a parallel, I'll always create three angles here that essentially add up to 180. And since they're always parallel, these will always alternate interior angles be congruent. It'll be in a key. Good to go. Complicate things, because life is not nice if it's just always too simple and boring and dull. So we need to find the values of x, y, and z here. So please talk about it. Which letter are we probably going to find first? Z, y, or x? Talk. So we do have, since I have two angles of this green triangle right there, that means I can quickly find out what x is. All right, so, and in that case, excellent. So 113, notice I do not have to put the degree symbol. Why? Because the degree symbol is already there. It's up there. So don't put it down here as well, because otherwise you would say 113 degrees, which doesn't make sense. All right, now we supplement that because linear pair are supplementary. And whoa. Did you see that 67 before? Did anyone see a 67 before? Yes. What? 28 plus 39 was the 67, which is this angle that's outside the green triangle. Scratch your heads. Always keep observing. I wonder if that's going to be true in other parts. All right, so now how do we find out what Z is if you're Korean, Canadian? Help us out, please. Good. So now that this is 67, we can add those two together, subtract that from 180 to get 49 for that. All right, because we are brilliant mathematicians, we look for patterns, and when we find patterns, we make a conjecture, and then we prove that conjecture in some way using our lovely friend, the proof thingamajigger. All right, so here's indeed a theorem. It's called the exterior angles theorem, and it says this. The measures of each exterior angle of a triangle equals the sum of the measures of the two remote interior angles. Woo! That was awesome. Any clue what that just meant? No. One major skill that I want to give to you and have you practice before you move on, because this is applicable to mortgages, it's applicable to signing tickets that you get from a police officer, it's applicable to college loans, anything, is you need to read through, and anytime you don't understand something, you make a note of it and never, ever be embarrassed to ask a question. I don't know. So what are exterior, what are interior angles? So it looks like this, especially regarding a triangle. So sketch this real quick. We have an angle here, a triangle. So let's call it angles 1, angle 2, and angle 3. These would be considered, our friend, the interior angles. Why? Because they're on the inside of the triangle. So they are the interior angles. So this guy here, and this guy here are inside the triangle. However, if I were to extend a side, so it kind of looks like a pinwheel, right? That little thing that blows in the wind, right? Now we have angles that are, supplementary to the interior angles. So let's call this one 4, 5, and 6. So the exterior angles would be the angles that are essentially the linear pairs of every interior. The linear pair of the interior. So, and it only applies to when you stretch it out. So, for example, I would not be talking about like this angle right here, right? Because that's not adjacent. That's more like a vertical angle to number 2. So it's vertical there. So this would be considered an exterior angle to 2, or this would be considered an exterior angle to 2. But we wouldn't talk about both of them at the same time. We're just talking about one of them when we are talking about it. All right, so now that we have this, notice that angle 1 is my exterior angle. Angle 1 is my exterior angle in this one. Now there is another exterior angle. It's drawn out here, but it's just not marked, so I'm not referencing it. Okay, so this is what it says. It says that the measure of your exterior angle is equal to the sum of these guys. That's what remote interior angle means. Remote means away from. So relative to angle 1, this is called my adjacent interior angle. That's the adjacent interior angle. So relative to 1, angles 2 and 3 are the remote, the angles that are away from angle 1. So how do we state that as a super secret formula? We'd say the measure of angle 1 is equal to the measure of angle 2 plus the measure of angle 3. And it doesn't have to be those numbers. Again, it's this outside is equal to the sum of these two interior. So how would we set up for this example right here? So here's an exterior angle. So I would say the measure of angle 1 is equal to, this is an interior that's remote, and that's the interior that's remote. So you would say they would sum to the 30 plus the 99. So the measure of angle 1, and it should make sense when we do it, is going to be 129, which is obtuse, and clearly that looks obtuse. Assuming that there is some sort of a scale. It's maybe not perfect to scale, but Generally, that's a good assumption, just to do a quick check. Go ahead and use this a little bit, and we're going to use this diagram at the right. So if we are told that two angles of a triangle measure 53, according to the diagram, where would you mark the 53s go?